Now let's move on to the sixth problem. Convert each of the following to logarithmic form. So we'll start with A. E raised to 2x equals k. 2x equals log base e of k, and we know log base e is natural logarithm, and we can rewrite this as natural logarithm of k. So 2x equals natural logarithm of k is our answer. Now let's move on to B. 10 raised to x minus 4 equals 9. So this is x minus 4 equals log base 10 of 9, or this is equal to log of 9. As we know, log base 10 can be written as lg, and from this x minus 4 equals log 9, or x equals log 9 minus 4, sorry, plus 4. Let's move on to the third one. 4 raised to x equals 2 minus k. So x equals log base 4 of 2 minus k. Now let's move on to D. E raised to x plus 5 equals m minus 2, and this is x plus 5 equals log base e of m minus 2, and we know log base e is natural log, and we can rewrite this as natural log m minus 2. So x plus 5 equals natural log m minus 2, or x equal to natural log m minus 2 minus 5. So either you can leave it like this, or you can simplify and write it as x equals natural log m minus 2 minus 5 by bringing this 5 to the right side. So that's about it. Now let's move on to the seventh problem. A. Log base 3 of y equals n plus 1. Fairly straightforward. Therefore y equals, so this will be 3 raised to n plus 1, the answer. Now we'll move on to B. Natural log of y equals x minus 3, and this is log base e of y equals x minus 3. So that implies y equals e raised to x minus 3. Now let's do C. Log x minus y equals 2, and we know lg represents log base 10. So this can be rewritten as, or it's same as log base 10 of x minus y equals 2. Therefore x minus y equals 10 squared. Now let's do D. Log base 2 of 4y equals p plus 1. This implies 4y equals 2 raised to p plus 1 is the answer. Now let's move on to the eighth problem. Express y in terms of x for each of the following equations. So basically we have to write this in index form by removing by converting logarithmic expression to index form, and make it as an expression y equals a function of x. So let's start with A. Natural log of y plus 1 minus x equals 0. We can write this as log base e y plus 1 equals x. We can take this negative x to the right side, and this is y plus 1 equals e power x, or y equals e power x minus 1. So we can bring this plus 1 to the right side and write it as e power x minus 1. So we have a simplified expression of this as y equal to a function of x. Now let's move on to b. 2 log y equals x minus 2, or 2 times log y equals x minus 2. And looking at this expression, LG represents log to the base 10. So we can write this as 2 log base 10 of y equals x minus 2, and we can use power rule to simplify this as y squared. So log base 10 of y square equals x minus 2, and therefore y square equals 10 raised to x minus 2, and therefore y equals 10 raised to x minus 2, and with this raised to half because we are taking square root, and this can be simplified as 10 raised to x over 2 minus 2 over 2 is 1, and we can write this as x over 2 minus 1. Okay, this is B. Now let's do C. E raised to 2y plus 4 equals x, and e raised to 2y equals x minus 4, and we can write this as 2y equals natural log of x minus 4. So if you bring e to the other side, we can write this as a natural log function, and this is y equals natural log of x minus 4 over 2. So this is the answer. This is C. Now let's do D. Natural log of x plus y minus 4x equals 0. So natural log of x plus y equals 4x by taking this negative 4x to the other side, and we can rewrite this as log base e of x plus y equals 4x. So this is x plus y equals e raised to 4x after we write this logarithmic function as in index form. So we want y, so y equals e raised to 4x minus x. So this is the answer.